Recording stopped. Ladies and gentlemen, I'd like to get your attention because we are going to commence our second day of the 10th ITB International Geothermal Workshop. The voice mic of the attendees and other panelists will be mute. Honorable participants, stakeholders, ladies and gentlemen, good afternoon. Hope everyone is healthy and energetic out there, ready for this important second day event. I would like to welcome back on this event. Yesterday was a great day, and this period will continue on today's event. I'm Rian Andriana, your host for today from ITB Geothermal Master Program. You're all welcome to this event that is live from Bandung. This is the 10th ITB International Geothermal Workshop 2021, titled with a theme, Synergy for Energy Transition, the role of geothermal energy in energy transition. Today's agenda will focus on data science, information technology, artificial intelligence, and advanced technology in geothermal. And there will be two sections, before the break and after the break. And there are 5 interesting topics of discussion and will be led by 2 moderators. I would like to remind everyone that our event is organized by the Geothermal Master Program, Institut Teknologi Bandung. A great acknowledgement also goes to sponsors, supporters, media, and committee who made this event possible. This event is one of the ITB Geothermal Master Program's commitments in supporting the development of geothermal in the country and beyond. And this commitment has made continuously. As for today, we held the 10th event that marks a decade of consistency. And we are not done yet, we just began. On remaining again, we're going to have 2 days left of series of events that will be live until the 29th of July 2021. Don't miss any and stay tuned with us. The paper presentation videos that has been sent to us can be accessed on our YouTube channel at Geothermal ITB. There will be an attendance form in the chat box that must be filled each day for all participants. The link for the certificates will also be shared to you through the chat box, as well as the respective emails after filling the forms. So make sure to check your chat box at the end of the event. Without further ado, let me introduce our first moderator, Mr. Dimas Taha Maulana. Mr. Dimas Taha Maulana is a professional, lecturer, and researcher in drilling and production engineering at Institute Technology Bandung. He also earned a master's degree in geothermal engineering at there. He will be our moderator for the next two topics. First, artificial intelligence for geothermal. Second, Ormat's innovation to deal with medium and low enthalpy geothermal resource, hybrid solar power and geothermal. And third, government exploration bureau. Mr. Maulana, time is yours.
All right, thank you, Mr. Adriano, for the brief introduction. Good afternoon, everyone. My name is Dimas Taha Maulana, and I will be your moderator today for the first session. Actually, we have two part of session today. The first will be discussing about data science and also advanced technology for geothermal. And at the first session today, we will have three speakers who are Mr. Jantiur Situmorang from PT AILIMA and Mr. Remi Harimanda from PT Ormat Geothermal Indonesia and Mr. Budi Lelono from Geological Agency of Indonesia. Before we start, I invite all of the presenter. Please welcome Mr. Situmorang and also Mr. Remi and also Mr. Budi Lelono. And before we start, we will take a picture together. Ladies and gentlemen, please the operator take the picture. 1, 2, 3. I assume the picture already taken by the operator. Okay, ladies and gentlemen, now we will start the first presentation. Will be by Mr. Jantiur Situmorang. He is a geothermal field evaluation and also on data science and software development, I think. And he's a founder of PT AILIMA, a company that delivers the consultancy of geothermal data science analysis. If I'm not wrong, Mr. Jantiur. And Mr. Jantiur also has numerous experience working in respected geothermal companies, both in Indonesia and also in New Zealand. And Mr. Jantiur Situmorang is graduated from Geothermal Master Program. He is our alumni. Okay, if you're ready, Mr. Situmorang, you can start your presentation. You have 20 minutes to open, and the participant will give the question for you through the Q&A button. So I will remind you all of the participant, please give your question through the Q&A button. And please avoid to using chat box because I'm afraid I do not realize that you give a question if you're using the chat box. Okay, thank you. Please welcome Mr. Situmorang. You can start your presentation. The time is yours.
Thank you, Pak Dimas. So I will share. All right. First of all, I would like to thank the committee of the ITB International Geothermal Workshop for the opportunity given to us to talk about the application of artificial intelligence for geothermal. So in this occasion, we will present one of the application in our cloud computing system that we have developed over since the last 2 years, which is called Jiwa Genius, which is the geothermal power generation early warning system, and it is embedded with machine learning. So I will talk about artificial intelligence and in particular the application of machine learning for geothermal industry. So probably allow me to start with the introduction about our company. We are a new company established in 2019. Our value is adaptive innovation. We are committed to provide a continuous new ideas and solution to respond to industry needs. And at the current stage, the company consists of 20 employees with various expertises from geoscience, engineering, AI, IT, project management, and etc. There are three main services that we are focused on. The first one is technology, geothermal softwares that provided through our cloud computing system. The second one is technical consultancy that we have involved in several projects during exploration drilling, the operation stage in many companies in Indonesia. And the third one is training. We have provided offline and online training for people development. So to start about the introduction about the AI, I will discuss some kind of classical problems that we normally face in many aspects of businesses, including in geothermal, is actually related with the lack of collaboration, that can lead to the ineffective of loss of productivity, and also related with the difficulty to access information, especially we are in geothermals, we are collecting a lot of data, and it's kind of sometimes it's kind of difficult for us to maximize the knowledge from all the data that we have gathered. And also there is an issue of accessing the data as well, because of the amount of the data is so huge. And then also there's a related to the manual task, data task. Some kind of automations already available, but still a lot of tasks still need to be done manually, and it actually we spend a lot of time for doing the manual work. So we lost the important time for decision making. So AI basically provide a solution through providing a collaborative environment. So if you can set up a system that can allow a better collaborative environment, and it can improve communication and collaboration. And AI also can empower human for decision making. So it can help us to make a better decision by considering all the data that we have collected that I believe is not very effective at the current stage. And it also can provide an effective and efficient time, because it helps with a more automation. And it basically, for engineers, reservoir engineers, for example, it can turn, if you are a great engineer now, AI can help you to turn you from a great engineer to super engineer, because you now have a better tools to help you work, to make a better decision, and also do a proper monitoring of the in the geothermal field. And so what solution that we provide, we called it as a Jiwa cloud system. So this picture is basically show the architecture of the Jiwa cloud system, which inside it will connect the database with the application in the cloud computing system, and inside also integrated with the machine learning. When you deal with a lot of data, it will be very helpful if machine learning also integrated. So later on, we will see how it will have us to gain more knowledge, probably crucial knowledge that we may not be able to find if we stick with the application of the currently or traditional technology. So it's also connected to user through multiple application, which probably required for a better flexibility. As long as you connected to the internet, then you basically can connect to the application. And in terms of geothermal industry, the software or application that is under development at this stage will help to do a better reservoir surveillance, to reduce drilling risk, resource assessment, and also perform a better resource optimization. So at the current stage, there are already some applications is completed and live in our cloud system. One of them is the wellbore simulator, and I believe that's the first one, the first complex wellbore simulator that it's run through the cloud computing system in the world. And currently, there are a couple companies, geothermal companies in Indonesia that already used our software, and also we provide services through this technology as well to support the development program, geothermal development program in many geothermal fields, including Ijen, for example, the exploration program in Ijen, which is already successful to demonstrate steam in one of the wells drilled there. And also we involved in the during operation stage, the management of the fields in Muara Labu and also Rantau Dedap, run by Supreme Energy. And also we provide the software for Geodipa to perform evaluation as a preparation of the Dieng Unit 2 and Patua Unit 2 development, that the drilling is gonna be implemented soon. So this is basically show the architecture, and now I will present one of the application inside this Jiwa cloud system, namely Jiwa Genius, the geothermal power generation early warning
Recording
system,
in progress.
which applied machine learning as tools to find a solution for us to do better monitoring, and also do optimization of the geothermal wells, including production wells, injection wells, but in the future also it can be integrated to the all elements or assets in the geothermal power plant, including surface facility and also the power plant. Well, I'm sorry, it's kind of stop the slide. All right. So a short introduction about machine learning. Nah, This picture is basically show how we, mankind, humankind, scientists, engineers, develop their knowledge is basically through experiments. But in pre-18th century, you basically have a lot of limitation to develop your knowledge, because maybe you can do a lot of experiments, but the way you uh, gather or develop the knowledge is kind of limited by the minimum implementation of mathematical equation. And then it progress. Mathematician help physician, or physician also who is really great in mathematics. They try to formulate the behavior of, for example, the physics of a flow through porous media, like in Darcy equation, for example. They try to formulate the equation, and then after that, they can use the equation to find a solution, and also the predict the future behavior of, for example, flow in a porous media. But it also has some kind of limitation, because normally when we do a research and try to develop one equation, it's basically the data is limited to the experiments that uh, performed during the research. So we know that a lot of cases can happen, right? It's not, probably it's unlimited, but it has to be a lot. For example, in the case of a Darcy equation, a lot of Darcy equation modification required for engineers to try to solve their unique cases. So a lot of unique cases, a lot of Darcy modification. We can mention that when you deal with a two-phase a flow, or probably three-phase flow, Darcy equation need to be modified. And when you deal with a different kind of geometrical flow, for example, linear, radial, spherical, also you need to modify that equation. And if you deal with a fracture flow through the fracture in a dual porosity environment, for example, a naturally fractured environment, you need to modify Darcy equation. And a lot of Darcy equation, and I guess a lot of PhD also, uh, was during the early of 20th century, 20th century, developed a lot of equation that is related to the Darcy equation as a modification. And but again, that one good, we have implemented that kind of technique, and it helps a lot us to understand our resources, for example, to try to characterize the reservoir, characterize the flow behavior in the wellbore, for example, or inside the reservoir using this kind of technique. But still, limitation relies on the how reliable the function you use related to the cases that you are trying to solve. And the third paradigm is basically model-based computation and simulation. So thanks for the improvement of the computer technology, and then we, in this paradigm, is basically we are able to simulate a complex geometry, a process in a complex geometry through the, for example, application of reservoir simulation or wellbore simulation in reservoir engineering fields. And recently, or probably not very new, probably already 10 years ago, it became very famous now that the application of fusion between the data-driven and also first principles of modeling. Now, instead of relying on the Darcy equation or the derivative of Darcy equation or modification of Darcy equation, if you have a lot of data, then you try to develop a knowledge from that lot of data using the machine learning. And we will see how the differences between the traditional programming and the machine learning after this slide. So basically, before we go to the differences, so we know in our daily life, machine learning have us a lot of stuff from doing online shopping. When you writing an email, there's machine learning or AI help you to prepare your email, to check your text. And when you try enjoy Netflix, for example, or YouTube, there's some kind of recommendation and a lot of example. Or if you like to play chess, you basically help by machine learning, because the application, the software also implemented machine learning in the application. And in terms of the types, there are 3 types of machine learning, which is first one is unsupervised, second one is supervised learning, and reinforcement learning. And in our cases that we will present here in GeoGenius, we implement at least 2 types of machine learning, which is supervised, including classification and regression, and also the unsupervised learning for clustering. So this is a simple picture to explain the difference between traditional programming and machine learning. Let's say if you are a reservoir engineer, you want to predict the production, let's say 3 months or 6 months or 3 years from now, for example. And with the current traditional programming, let's say you use a wellbore simulator, you need to prepare and gather a lot of information, including the data that you collect from the surface and the data that you collect from the downhole monitoring survey. It can be pressure, temperature, spinner, can be a transient test, a lot of information actually you will collect. And you do modeling by trying to match with the historical data using the function that you have in your wellbore simulator tool, for example. There are a lot of two-phase equations implemented for two-phase flow modeling. For example, you can mention Hagedorn-Brown, Orkies-Wesky, Beck-Brill, Dance-Rose. It's basically a lot of equation available there, because one equation is actually good for one case but not good for the other case. That's why a lot of equation is implemented in the wellbore simulator. And then using that rule, you try to predict the answer, and then you try to match with your data the answer, which is the mass flow rate, and you do a trial and error process. This basically we have implemented.
Mr. Situmorang, sorry, your time is up. Maybe you can finish your slide here.
Okay. Now the machine learning is actually implement different kind of a process. Instead of forcing rules there, it will find the rules for you. So you need to prepare a lot of data first, the date or well pressure and mass flow rate, and then with the machine learning algorithm, you can find the rules, and the rules is updated when the data is updated. It's basically the difference between the machine learning and the traditional programming. So, Pak Dimas, should I stop here?
Yeah, maybe after this we can discuss more by the question and answer, Mr. Situmorang.
Correct. Actually, there are 3 slides more, but yes, if I have to stop here, I will stop here.
All right, thank you, Mr. Situmorang. We are really sorry because our time is really short for this session, but actually you can give more as knowledge by the question and answer maybe. And I think Mr. Jantiur still have many slides after this, yeah, right, Mr. Situmorang?
Yeah, like three slides is basically probably this is the latest slide.
Okay, okay. You
If
can
I
still
yes.
explain this last slide.
Okay, all right. So I skipped there are two slides there. I skipped. So basically, this is show how the process is going on in Genius. So instead of requiring a lot of data, including subsurface and surface data, the Genius is basically only need surface data. So basically, you can reduce the amount of data you require for the analysis, and it still provide a very good result in terms of monitoring the production and injection decline of the geothermal fields. For example, in this case, you have more than 20 years data, field data, and then you put that into the software, and then the second process is the software where the machine learning algorithm inside, you can basically review that one. We published the algorithm in Stanford geothermal workshop, and for 20 years of data, it basically would require less than 15 minutes. Normally, with traditional techniques that you normally perform at the current stage, it may require weeks or even a couple of months. So with this kind of technique, it's basically work faster. It's only a couple of minutes for you to be able to review the performance of the well. And we here this kind of a new technique for us to visualize the results of the machine learning is using we create a chart named CWP scan, which is called as a computerized well performance scan. It produced after 10 minutes of process, and then you can do a vertical slice from the chart to get an output curve, and then horizontal slide to get the production decline as you wanted. And the chart is basically also you can really quick review the time where you have anomaly behavior. For example, here the color showing you the abnormal behavior in 2010. And also with the application of unsupervised machine learning, we do a clustering to find a region where you see a different behavior of the well performance, and also you can basically monitor the variances, the difference between the expected with a normal decline compared to the actual. So when you see the actual production is lower than what you expect, then you think something wrong must be going on, and then you can go to check your data, and also probably to perform immediate action to avoid any losses, possible losses on your production and injection. That's probably the slide that I would like to share.
Okay, thank you very much, Mr. Situmorang. That was very interesting knowledge for us related with the using of machine learning, right? And now we already have some question. Maybe the first I will read it for you, Mr. Situmorang. This from Heru Berian from Geothermal ITB. Mr. Heru asking you about, is it possible that AI can replace replace the engineer regarding to the decision making? Maybe. What do you think, Mr. Situmorang?
Yeah, I don't think so. What I mentioned before is basically AI can transform you from a good or great reservoir engineer to be a super reservoir engineer. but it will not.
So is it complete you, right? Not
Yes.
replacing you.
Yes.
Thank you for the comment, Mr. Situmorang. And I would like to jump to the next question. Please, operator, can you? Okay. The question is from Lauro Bayrante from AWPRB Drilling. He asking about how has the application of Jiwa cloud system solution can reduce the risk and increase the success drilling rate new area compared to historical exploration drilling in Indonesia. I think he's asking about the success ratio or maybe the drilling target. Mr. Situmorang, can you please give a comment?
Yeah, the number of application is not quite a lot yet, so it's hard to say the success ratio because you have basically limited of information at the current stage. But what I can say, in the Jiwa Cloud computing system, there are applications that help you to define, for example, if you deal with a greenfield exploration, you by do collaboration on geochemistry data, for example, geophysical understanding, and also reservoir engineering concept, you can better predict the location of top of reservoir. That's already implemented in one of our field experience. And you can also do a Monte Carlo simulation using Jiwa Cloud system, which basically help you to understand the risk, as this question is related with the risk. The risk when you are going to drill, normally you will do a kind of a risk assessment in the beginning. That's also related not only with the drilling activity, but also the resource capacity itself. So it's basically what we have at the current stage in the Jiwa Cloud system, but I cannot say in terms of success ratio because the data is very limited.
Okay, so it can say that many more data that you have, it will better interpretation by the data science, right, Mr. Situmorang?
Yes.
I think we still have for one or two questions, Mr. Situmorang, and this question is coming from Tony, ITB. Do we already utilize AI to help us make decision during exploration? Sorry. And how is the accuracy based on your experience, Mr. Situmorang? Can you explain to us?
Okay. If the AI is related with the application of machine learning, I have to answer no, not yet. But if you say the AI as a traditional AI, is basically yes, without incorporating machine learning, just a traditional artificial intelligence where the machine or the computer helps you to calculate or to try to predict the better location for drilling, for example. And basically in area of drilling, there is a lot of opportunities that you can implement AI. One of the possibilities is mitigation of stuck pipe during drilling, right? If you have a lot of information, probably for a company that already developed a lot of fields, gather a lot of information, more than 20 years operation, they have a lot of information that related to the drilling, and probably they can develop a new knowledge how you can predict stuck pipe or stuck during drilling. But again, it depends on how many data you have, and then how good you manage your database, and then digitalize your information before you are able to implement machine learning for that kind of purposes.
Okay.
So there's a lot of opportunities actually, but as Karen says, I think it will require a lot of effort in order to make the kind of things happen.
Okay, thank you for your comment, Mr. Situmorang. I think we still have the next question from Taufik Rahman. Mr. Taufik asking about, based on the collaboration between PG and LNUSA, about two-phase flow measurement that will produce real-time data with a high level of accuracy. How does the AILIMA see this opportunity to enhance or to make a wider AI application in geothermal?
Yeah, if I understand the question, this is related with the measurement of two-phase flow, right? Yeah, there are a lot of techniques that is used. There are tracer, there are jam slip tracer, there are using electromagnetic. There are a lot of techniques. Probably you can explore using AI if you have a lot of information from the well pressure, delta pressure you have through the orifice. Probably you can develop something new from AI using AI to predict the mass flow rate. So the objective is for the optimization of the number of measurement or testing that you will require, because normally you need a lot of testing. For example, like a TFT, you need to do a lot of TFT in order to calibrate your flow measurement, for example. And probably we can develop something from AI as long as you have a lot of information to optimize that kind of cost.
I'm a little bit curious, Mr. Situmorang, how we can decide is our data is enough to analyze or not?
Yeah, if you have a lot of data, that's good. But in the modeling process, because I didn't, there's one slide that actually explained that one, but I skipped that one. The process will consist of in machine learning consists of one of the process is model building and testing. So that's how you would see whether your model or your algorithm, machine learning algorithm, can provide some kind of solution with good level of confidence or not. That's why you need to do research first before you get the answer whether it is possible or not. But in our experience, we did like 2 years for the algorithm development for the two-phase flow decline measurement. So that's a lot of efforts in order to make the kind of things happen. That's from the algorithm development, software development, the cloud development.
Okay, thank you for your explanation. I think we will still have one question again from Mr. Yuris from Geodipa. The common tools to simulate the reservoir behavior of or predict the lifetime of reservoir is by the numerical simulation. Can the AI helps this or even improve the methodology to make it easier and provide a better decision analysis? Maybe you can explain more about the implementation of AI to help reservoir simulation, Mr. Jantiur.
Yeah, I think that's very possible. That's very possible. One of the research done by the MIT, if you can do Googling, they develop kind of machine learning to do a quick processing of that kind of process, the 3D flow process using Navier-Stokes equation, and they mentioned it 1,000 faster than the current numerical simulation. So it's very possible. I think, again, it depends on the data that you have. Probably the first step, if you have some limitation of the data, you can create the data from the current modeling software. You create a lot of data, and then after that, you try to simplify that one using the machine learning techniques, and it basically will improve and improve the time that you will require to perform reservoir simulation.
Okay. Thank you for your explanation again, Mr. Situmorang. Unfortunately,
Yes.
we have no more time to discuss. Again, I would like to say thank you very much, Mr. Situmorang. And there will be a memento for you. Commonly, we will give you.
All right.
But
good.
Because the pandemic, the committee will send to you, Mr. Situmorang. Thank you very much again.
Okay, thank you very much, Pak Dimas.
You're welcome, Mr. Situmorang.
All right.
Oh, all right, ladies and gentlemen, I would like to finish Mr. Situmorang session, and after the sponsorship video, we will continue to the next presentation. Please enjoy the video.
Cuma rebahan, tapi bisa bikin perubahan. Waktunya mulai bisa apa aja dari satu aplikasi. Mulai adaptasi cara bayar baru.
Bisa, kan pakai kris. Jadi mudah.
Mulai eksplorasi cara tarik tunai baru.
Ya bisa. Dengan mobile tunai, gak perlu ribet.
Mulai melihat potensi bisnis baru.
Bisa dong. Transfer luar negeri cukup dari sini.
Oh, itu aja ya?
Enggak. Bani Mobile Banking punya banyak fitur yang buat kamu bisa apa aja. Bisa investasi, buat live goals, kirim digital kado,
bayar tagihan rutin, top up e-wallet,
dan berbagai fitur untuk transaksi lainnya. Aku aja punya Bani Plus dan Bani Mobile Banking.
Yuk, buka tabungan dan aktivasi sekarang.
Cukup saldo
Dengan tampilan BNI Mobile Banking baru,
mulai bisa apa aja sekarang.
All right, thank you, ladies and gentlemen, for stay tuned with us. Now we will jump to the next presentation. Will be from Mr. Remi Harimanda from PT Ormat. He is technical director of PT Ormat Geothermal Indonesia, and Mr. Harimanda will talk about to deal with medium and low enthalpy geothermal resources. But before we can start, I would like to invite Mr. Situmorang and also Mr. Remi Harimanda. And if you dare, Mr. Eko Budi Lelono, please turn on your camera because we will take a picture again. Okay, maybe Mr. Eko Budi Lelono not at his chair. So we will take a picture on, please operator, stand by. On 3, 2, 1. Okay, thank you, Mr. Situmorang, for joining us again. Okay, Mr. Harimanda, maybe you can start your presentation if you are ready. Please, the Zoom is yours.
Ya, betul ya. I'm very sorry that I cannot join this webinar with my computer. I don't know what happened with my computer or my account. So maybe the presentation will be assist by the committee for my presentation. Okay, thank you, and also Assalamualaikum. In this session, I will present Ormat innovation to deal medium and low enthalpy geothermal resource. Actually, as I was instructed by the committee to emphasize on the hybrid solar power with the geothermal. So in this session, I will focus in this topic. But if time still available, yeah, I will continue with the other topic. Okay, next. Okay, next. Okay, this is the list of topic that I want to present to you, to all. The first is of course the Ormat introduction, maybe just for the refreshing for the others participant, or maybe for the new audience that doesn't know who is Ormat. And then the second topic is hybrid solar. The second topic is the Ormat binary technology, and the third topic is the hybrid solar power with the geothermal power plant in our geothermal power plant in Tungsten, Nevada. And the other topic is also zone utilization, then pump geothermal wells, and the last is the recovery energy generation. But again, maybe I will emphasize on the solar hybrid with the geothermal power plant. Okay, next. So this is just for introduction. Who is Ormat? Actually, as you know, Ormat actually is a market leader in the geothermal sector. And then our mission is to become the renewable energy provider, the leader in this sector. And our company established in 1965. So currently the Ormat is already 76 years old, older than me, and also Ormat now own and operate 1,000 megawatt for the geothermal power plant, solar storage system, solar power, and also recovery energy generation. Yeah. So next. So this is our track record, successful track record. We already built the geothermal power plant. The total capacity is almost 3,000 megawatt for the 190 power plant. And then we also developed the energy storage system. The total capacity that we already installed is 73 megawatt. And the other is solar power. In the right side, the solar power, we already built around 47 megawatt, which is one of the project is the hybrid with the geothermal power plant. And the last successful track record is the recovery and generation. In this recovery and generation, actually, we use the heat waste from the industrial sector that we convert to the electricity. Okay, next. So this is the power of experience of Ormat. Our technology can handle the heat source from lower temperature, 75 degrees Celsius until 530 degrees Celsius. So this is the span of the heat source that we can handle. And also our capacity that we already install from micro means below than 1 megawatt install capacity, mini 1 megawatt until 5 megawatt, and also the larger capacity above than 10 megawatt. Yeah. So we already built all many various capacity for the power plant, not only for the geothermal but also for the recovery energy generation. Okay, next. Okay, this is our operation in the world. Actually, our power plant already in place in every continent in the world. Yeah, you can see our power plant already installed in USA, in America, in Africa, Europe, Asia, also Australia, and New Zealand. Actually, New Zealand is in the Australia continent. Okay, next. Okay, this is just for the refreshment for our technology, especially for the binary or organic ranking cycle technology. Okay, Pak. Next, Pak. Okay. Actually, the appropriate technology for the geothermal analysis is totally depend on the enthalpy of the geothermal fluid. For the example, if the temperature of the geothermal fluid above than 200 degrees Celsius, it means the geothermal fluid will consist only the dry steam. For dry steam, the appropriate technology, of course, only the steam turbine is most efficient. But again, sometimes the dry steam mixed with the non-condensable gas like CO2 or H2S. So for this reason, if there is a NCG in the dry steam, there is two options of the technology. One is the steam turbine with the vacuum system if the NCG is low, below than 2%. But the other alternative, if the NCG is bigger than 2%, it means that binary is the option and more efficient, I think, for this kind of the geothermal fluid. Lower the temperature of the geothermal fluid, it means that can be a mixture of the steam plus brine plus NCG, or steam plus brine only, or even liquid only or hot water only. For this, of course, binary is the solution for this geothermal fluid. Okay, next. So I just give the illustration. This is the conventional geothermal steam turbine. You can see in the picture that first the geothermal fluid to be extract or to be feed into the sparator to split the steam and also the brine. The steam will enter to turbine to be expand. Then the extra steam to be condensed again and mixed with the brine and then to be injected to the reservoir. So this is the configuration of the conventional technology. Okay, next. So this is the configuration of the binary or organic ranking cycle technology. You can see in this picture that first the geothermal fluid, mostly for this configuration, geothermal fluid is hot water only, or the temperature of the geothermal fluid below than 150, above 100 degrees Celsius, of course. And then the geothermal fluid cannot be self-flowing, so we have to pump. So the geothermal fluid will enter to the vaporizer first to release the sensible heat. Then the geothermal fluid to enter the preheater to release again the sensible heat. After that, the geothermal fluid to be injected to the reservoir. You can see in this configuration that all the geothermal fluid to be injected 100% to the reservoir. There is no geothermal fluid to be exposed to the atmosphere, to the environment. So this is very friendly for the environment. And for the secondary process, you can see that there is a motif fluid. We use isopentan or hydrocarbon base for the motif fluid. The motif fluid first to be pumped by the motif fluid pump, and then to enter the preheater to absorb the sensible heat from the geothermal fluid until the boiling point status. After the motif fluid achieve the boiling point, the motif fluid to enter the vaporizer to convert the liquid phase until 100% vapor. After that, the vapor of the motif fluid to enter the turbine to be expand, then the exhaust vapor to be condensed in the air cooler condenser. You can see that mostly binary power plant from Ormat will use air cooler condenser, not water cooler condenser. Yeah, this is the also the advantage for the implementation of the binary power plant. Yeah. Okay, next. So in the next slide, in this slide, you can see that the major component of the binary power plant consists of the first is the turbine, of course, and the second is the condenser. The third is vaporizer, preheater, and then the multi-fluid pump. Yeah. This is the major item that has to in the binary power plant. Yeah. Okay, next. So, in case that the geothermal fluid to be mixture of the steam and brine, of course, the first step is to split the steam and the brine. The steam to enter the vaporizer to be condensed. Then the condensed steam to be mixed with the brine, and then the brine and the condensed steam to enter the preheater. After that, all the geothermal fluid to be injected back to the reservoir. The other process is the secondary process. The multi-fluid cycle is similar actually with the previous one. So we can continue with the next slide. Okay. Okay. Next one. So this is the configuration for binary. If the geothermal fluid having the high temperature, high pressure, so the geothermal fluid firstly to be spirit in the sparator, the steam and the brine. The steam to enter the back pressure turbine. After steam enter the back pressure turbine, the exhaust steam to enter the vaporizer in our heat exchanger in the binary cycle. Yeah. So you see in this configuration, if the geothermal fluid has high temperature, high pressure, we can combine with the back pressure turbine. Back pressure turbine is similar like a steam condensing turbine, but the exhaust pressure is still above the atmospheric pressure. Yeah. Usually we set the exhaust pressure of steam to be 1.4 bar. Yeah. So yeah, the other is for this the IGCCU is combination between the back pressure turbine, brine unit and bottoming unit. Yeah, you can see this configuration already installed in Sarula in Sumatera Utara. The total capacity is 330 megawatt. Yeah. So you can see that this is the first binary project having the biggest capacity in the world actually for the binary. Yeah. Okay, next.
Mr. Harimanda, I'm sorry, you still have 2 minutes left.
Oh, okay. Okay, you can skip with the hybrid solar power. So this is hybrid solar power and geothermal. Actually, there is 2 options of technology for the solar power. First is the photovoltaic, and the second is the thermal. Yeah. For the photovoltaic, yeah, we already understand that actually the solar energy radiation or sunlight consists of the photon energy to convert the photovoltaic photoelectric cell to electricity. But for the thermal, actually we concentrate the solar power to heat the brine or maybe the multi-fluid to get additional heat for the cycle. Yeah. So for this case, actually, we just implement the photovoltaic for our existing geothermal power plant. Okay, next. So this is just for the information that actually PV module and balance of system consists of the first is the PV module, and then the balance of system consists of the wire that connect, and then inverter, charge controller, also some ground mount PV array to employ a solar tracker. So next.
Sorry, maybe Mr. Harimanda has lost his connection, maybe. Please wait a minute, all participants. The committee will contact the Mr. Harimanda.
Can we continue our slide?
Yeah, Mr. Harimanda, you're back with us. Okay, maybe you can finish this last slide, Mr. Harimanda.
Okay, this is our project.
Okay, hello. We lost the connection again.
Sorry, I have trouble with it. Okay, I will continue first. This our project in Tungsten, which is a hybrid with solar with the geothermal power plant. Actually, we use the solar to cover the parasite load for the power plant, for the Tungsten power plant, and the Tungsten power plant, actually the installed capacity of the power plant is about 28 megawatt. So we use a parasite load about 25% for this project with the solar power.
All right, Mr. Harimanda, are you still with us? Okay.
Okay, Pak. Next for speed up.
Yeah, I'm sorry, Mr. Harimanda. Time is up.
Oh, okay, no problem.
Really sorry. Yeah. Yeah, to all the participants, actually, Mr. Harimanda should join us soon at the session because the technical issue. We are really sorry to, especially to Mr. Harimanda. You cannot join soon because the technical issue.
I don't know the
yeah. And also, unfortunately, because the time is really limited.
Okay.
Maybe we jump to the question and answer, and maybe just one question for you, Mr. Harimanda. Is it really sorry? And the question is maybe from I will choose from Aditya Yuda. From ITB, and the question is, yeah, there are several medium enthalpy geothermal resources that will be explored by the government drilling in upcoming years. In your perspective, Mr. Harimanda, what do you think about it? Is it really interesting to develop?
Sorry, I just lost connection. So can you repeat the question?
Okay, Indonesia will actually have explored some of a field by the government drilling, and some of them are medium and enthalpy resources. In your perspective as Ormat, is it interesting or not to develop as a power plant? Hello, Mr. Harimanda. Okay. Really sorry to everyone because Mr. Harimanda lost his connection. I think I will end this session. Maybe we can discuss again with Mr. Harimanda okay. Mr. Harimanda.
Sorry, Pak. The connection, I don't know yet. Always on off and off here.
Okay, maybe your last statement related with is it a perspective in Indonesia to develop a medium
I think
and medium enthalpy in the future?
It's still perspective here to develop the low and medium enthalpy, because of course, if God.
Okay, we're losing Mr. Harimanda again. Okay, ladies and gentlemen, maybe I will to end this session. Unfortunately, I'm sorry, and we will jump to the next presentation. But before that, we will have sponsorship video. All right, ladies and gentlemen, thank you for staying with us. And now we will jump to the next presentation. And we will discuss about the government strategies to reduce risk in geothermal exploration with the topic of exploration geothermal drilling, especially conducted by the Geological Agency. What is it and how is it implemented? We'll have the Honorable Mr. Eko Budi Lelono to share his knowledge about this topic. And Mr. Lelono is the head of the Geological Agency of Republic Indonesia. And as we know, currently Badan Geology or Geological Agency has planned to drill into location in Indonesia, in Cisolok and Nage. Maybe it will start soon, the drilling, or maybe already start. Mr. Lelono will share to us later. Okay, ladies and gentlemen, without further ado, please welcome Mr. Lelono. If you're ready, you can start your explanation, Pak.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Thank you, Pak Dimas. As mentioned by Pak Dimas, today I'm going to present what we have been doing so far in the field of the geothermal exploration. The title of the presentation is the Government Geothermal Exploration Program. Next slide, please. So let's take a look with our potentiality, geothermal potentiality in the country. We have 357 locations that contains geothermal energy, and the total resources for this location are about 23,000 megawatt equivalent. But the reserve that has been calculated is about 14,000 megawatt equivalent. Unfortunately, only less than 10% of the total resources that have been utilized. Next slide, please. So this is the title of the area that has been explained earlier. We identify eight islands here that yield the geothermal energy. I also identify some locations of each island here, and also we calculated these possible resources and also the reserve. As I mentioned earlier, that this utilization of this energy is still minimum. So we see here, for example, in Sumatra Island, the utilization of the energy of the geothermal energy is from 744 megawatt. So we need to improve this, the use of the geothermal energy in order to support the government policy to use the energy and renewable energy. Next slide, please. This is the flow chart of this geothermal business here in Indonesia, where we can see that the government mostly do the preliminary survey and the exploration, general exploration, whereas the companies or business activity performs further bigger exploration, civil study and exploitation. However, Badan Geology, in this case, representing government of Indonesia, move further by performing the 3G exploration, also the test well test, and then exploration well. The result of this survey and the analysis will be used to propose working areas to be submitted to the Director General of Energy in order to offer the company. Next slide, please. So the Badan Geological Agency contribute in the seven areas to the primary exploration survey, prospect evaluation and geothermal resources, recommendation of geothermal area for preliminary survey assignment, and the preliminary survey and the exploration assignment. And also the geothermal working area foundation. We also provide data and geothermal balance of Indonesia measurement, and then also development technical assistance and the new distribution geothermal development to community and stakeholders. Next slide, please. So what we have been doing in the field of the geothermal survey and exploration. Next slide, please. Now, these 5 activities that have been doing by Geology, including the first is the primary survey. This is aimed to find out the geothermal prospect at the level of speculative resources. We also perform the survey, geology, geochemistry, or geophysics. Yeah, and here is as the 3G exploration, which is to find out the geothermal prospect, the level of possible reserve. We also do the manufacturing survey to delineate location and destination and dimension of more geothermal prospect. Then gradient thermal drilling to determine sustainable condition and thermal gradient. And then finally we do exploration drilling in order to determine physical pressure, stability, and chemical property of reservoir. Next slide, please. So having the facts that the our resources is quite large, where Indonesia is a second position in the world actually, but the utilization is still less than 10%. So there is necessary to accelerate geothermal development, encourage for the geothermal industry as the strategy. This is to improve the quality of geothermal geoscience, scientific data and information, and to reduce development risk before geothermal areas are offered to the business entity, and also to improve the economy of the geothermal project to become more competitive. Now, this is we propose this geothermal exploration program for the period of 2020 to 2024, and the scope of this program will be data acquisition, is including addition of geoscience data, some survey will be done, and the integration of data acquisition result, conceptual model analysis, reservoir model solution, data targeting, and field review, and infrastructure development. This is including land acquisition, preparation of road and well packed infrastructure and sporting facilities. And finally, we perform the exploration drilling, at least 2 swim holes, wells here, and 1 standard well for each location. One location, I will tell you better. So the implementation this program, the implementation program, is to select 20 prospect location, according to two criteria, technical and non-technical. And this the implementation plan cost about 357 billion rupiah for each location. Now, according to the estimation of the Director General of New Energy and Renewable Energy, this program will reduce the price of the electricity from 0.42 up to 2.53 cents US dollar per hour per kilowatt hour. And then also this will benefit during 30 years term of electricity sale and purchase agreement are about 2,500 million US dollar. Next slide, please. Well, this is selected area, 20 selected area that we propose in the program. It will be drilled during that period, 2020 and 2024. Sorry. As you can see, prospect area that we have 25. Also, the province where the location where the prospect area is located, and then the status of the area. Also, resources that need to be found, and that's also the potentiality of the development plan. So next slide, please. I think this is only show the map of the location that will be selected location for the exploration, and each location is completed by the potential of potential. Okay, next slide, please. So, what is the stage and also methods, that we can perform for to perform this project, So we will start by doing design data acquisition that includes sensing, the survey, the chemical, and also geological, and the gradient thermal drilling. This will be used for the design data acquisition, and then evaluation of well targeting and field review, and we also will perform conceptual model analysis and simulation. And the planning, evaluation of geoscience data acquisition result, also conduct infrastructure development. This is also important, this is aim to drill the location, and then further completion and production test, and then preparation of feasibility study document. This is the stages and the methods that we will conduct in this program, and at each stage will involve third party consultant in order to have accurate data survey and accurate result. Next slide, please. This shows the current activities. We perform acquisition data of geothermal 3G in 8 different locations. This is prepared, this acquisition are prepared for the next program, the program. And then also this year we drilled two areas in Cisokarangi, Bandung, in West Java, and in Nage, in this Timor. The progress of this two full drilling is still still in progress. We will finish this by the end of this year. Next slide, please. Yeah, I think this the timeline in the of this year, So you can see here that we start from January, then we finish in December. Including drilling sea boats into the different area. Next slide, please. Next slide, yeah. This slide only show you the interpretation result in the Solok area by the geological team. Of course, if you want to know the detail of this interpretation, my colleague will explain maybe in the different forum, yeah, because this needs a long explanation. Basically, this is performed or conducted in order to select this well targeting, yeah, so that we can have a maximum potential in this area. Next slide, please. This is for the NADI, yeah. I think all this has been only studied and been finished, and then so we have a location, oil location, yeah, for each area. Next slide, please. Next slide, yeah. Okay, this is location of in the Diwan, yeah, South Sulawesi. But unfortunately, this area will be drilled next year, yeah, because we have a sending plan here. But the study has been done, so next year we have also define this location by location. I think next year or next coming year, what we are going to do is to drill this location. Next slide, please. Yes, I think is the kind of information regarding the location of the well in the Solok area. You can see there that we will drill two wells, yeah, namely Jakarta 1 and Jakarta 2. Yeah, this is the current situation in the area that we build the infrastructure, yeah, road and welfare also. Next slide, please. Now, as I mentioned earlier, we involve third party in Solok. The one who drill is a symbol in the Solok area will be Remi gas, yeah. They have they build as an engineering product the what you call it, rig, yeah, here. And next slide, please. Next slide. This is equipment for next slide. Yeah. Okay. Sorry. Okay. Next slide. Yeah. This is no. Previous slide, please. So this is the location that slim hole in Nage. Yeah, compared to the one in Solok, Nage is rather shallower. So then the area also near the main road, yeah. So it will be slightly not too difficult, yeah, to build by the access to the location. But again, the problem with this the drilling program here is how to communicate with the community, because then we have to we have to free their property, land, and also the utilization. This is a long negotiation with them, and also as you may understand that the location of this well, all the many geothermal wells are in the so-called hutan lindung. Yeah, so we also need to deal with this mystery, yeah, in order to have permission to drill the geothermal well. So next slide, please. For the landing location, we are supported by third party. This is that provide rig, it's very new rig. So hopefully this rig will operate well, and they will be brought to this Timor. Next slide, please. So as the closing statement, the Geothermal Smelting Project by the government is one of the national priority project. Yeah. So the thermalization would be done to support new renewable energy target achievement in energy neutral to evacuation of national electricity and also contribute in reducing greenhouse gas emission. And second, that the evacuation by government will increase the competitiveness of electricity price of geothermal and provide for the local and national economy development and state. Next slide, please. I think this is the last slide. The last slide. Thank you for your attention. I return time to moderator,
Dimas.
Dimas. Thank you very much.
Okay, thank you very much for the informative knowledge, Mr. Lelono, that you share with us. Now we already some of question, Mr. Lelono. Maybe I will read it for you. The first question is coming from Ivan from ITB. And the question is, what is the consideration of a geological agency in deciding the 20 prospect areas for geothermal government drilling? How to select these 20 prospect, Mr. Lelono?
Ivan, I think I mentioned earlier about this. There are two technical and non-technical criteria. For the technical criteria, for example, we consider deep source, reservoir temperature, geological structure, pre-type manifestation, pre-type completeness of geoscientific data and infrastructure quality. And for non-technical, we consider the use, electricity demand, and the social acceptance condition. As the additional information that we selected this area by involving the other units, yeah, within this within the resources, and also we consider this other perspective coming from outside the Ministry of Energy and Resources. So I think it's already been discussed many times. Yeah. But of course, if you have other opinion, then we would like to hear that. And maybe you have more complete data, then it is possible that we consider this. But again, we already not arguing, but many parties and we have spent many of time to have a same perception about these areas. But again, if you have a more accurate data or more complete data, then we like to hear them. Thank you.
Thank you, Mr. Lelono. So it can be said that these 20 areas, there has the most confidence level, the highest confidence level, right, Mr. Lelono?
Yeah. Yes, based on our data that we have, and data from other sources as well, like those from development of new energy, so maybe from other sources, maybe also from your side as well, from the ITB, for example, or probably.
And is it also the same reason to choose Cisolok and Nage fields, Mr. Lelono?
Yeah, it's the same reason, yeah.
For the first stage of exploration drilling. Okay, thank you, Mr. Lelono. I will jump to the next question. From Betseba, ITB. And the question is, we are aware that currently the government has the ongoing government drilling program, which is Cisolok and Nage. If by any chance during the drilling process the expected resources is not met, that means less than expected or fail, what will happen to the government fund, Mr. Lelono?
Yeah, this is something that we also we are thinking we think very carefully in the early stage of this program in order to ensure the well-patient, because this will use quite number of the government budget. Of course, there is a possibility that we fail, for example, to find the heat, but we hope that the program will succeed to find what we have expected. Of course, we need to conduct this program based on the scientific really prudent, scientifically, and also accountable, in terms of using the finance that we use for this project. Hopefully, that this will we really hope that this succeed. Thank you.
Thank you for the explanation, Mr. Now I will go to the next question. Coming from Pak Bonar Marbun, I think it's from ITB. The question is, does Geology Agency have reliable, accountable method to measure the success level or key performance index of exploration government drilling program? Thank you very much. Please give the comment, Mr. Lelono.
Yeah, Pak. Good. I think from the beginning we set this program very carefully. We try to apply the best method, as I mentioned earlier, that what we are our activity here involving the third party, the quality consultant from inside or outside the country, both, abroad, that give us the best methods, and the best way to decide which method and which location that the best location for drilling. So I think, well, if I really need time to discuss this in really sufficient time. I think this is the short time to explain. But yes, we have a sufficient reliable method to do this project. Thank you.
Okay, thank you for your explanation, Mr. Lelono. I think we still have 10 to 15 minutes for question and answer, Pak. And the next question is from Tony from ITB. And the question is the data from government exploration drilling will be open to public, Pak, especially for academic research purposes? Is yes, when it will be available and how to access it?
Because we use, well, the program is are funded using the APBN. Government budget. So I think this will be open to public, and especially for the university can use this. Maybe for teacher benefit, to evaluate the program, the government program, in order to have a better the program in the future, progress every year. Because as I mentioned earlier, this program scheduled from 2020 to 2024, and we have a vision implement by drilling for this location. So I think any university or any other party would like to use this data for evaluation and for study, especially in the university. I think it will benefit also parts. Thank you, Pak.
Thank you, Mr. Lelono. I'm sorry, I was mistaken. The time is up, Mr. Lelono. Unfortunately, maybe we can discuss again in the future, Pak. And thank you again. We hope the drilling at Cisolo and Nage will be successful.
Okay. Thank you, Pak. Thank
you, Mr. Lelono. And we have a memento for you, Pak, for the appreciation for your time and this discussion. And the committee will send to your address. Thank you very much, Pak.
Assalamualaikum
warahmatullahi wabarakatuh.
Assalamualaikum.
Now, ladies and gentlemen, we have arrived at the end of this session. I'm Dimas, Maulana, moderator of this session. Would like to thanks to all of you, the presenter and all of the participants who have joined the session today. I hope that the knowledge and discussion will benefit to you all and support the geothermal development in Indonesia in the future especially. Well then, I will return this event to Mr. Adriana as MC. Thank you very much. Please, Mr. Adriana, the event I give back to you.
Okay. Let's have a round of applause to our esteemed moderator, Mr. Dimas Maulana. Thank you for guiding us throughout these two topics of discussion. We would also want to thank Mr. Jantiur Situmorang, Mr. Remi Harimanda, and Mr. Budi Lelono for the information and great news of geothermal development. As stated before, The memento will be sent to you after the event due to the current situation. Once again, thank you for your time and knowledge you share in this event. Before we proceed to the next session, we are going to have a break for 20 minutes. Stay tuned with us, because after this, we will have one section with 2 more topics about the update of geothermal development in Tanzania and factor characterization for optimum well placement. We'll be right back. Thank you.
Indonesia merupakan salah satu negara yang memiliki potensi energi panas bumi terbesar di dunia. Saat ini, Indonesia menduduki peringkat 2 dunia sebagai negara penghasil listrik dari energi panas bumi. Selain sebagai energi yang bersih dan berkelanjutan, peran energi panas bumi sebagai baseload penyediaan listrik menjadi pertimbangan utama agar pengembangannya diprioritaskan. Oleh karena itu, dalam menjaga ketahanan energi suatu negara, energi panas bumi dapat menjadi andalan untuk memasok listrik guna memenuhi target bauran energi 23% EBT di tahun 2025, sesuai dengan amanat dari Kebijakan Energi Nasional. Untuk memenuhi pencapaian target EBT, dalam bauran energi tersebut, Indonesia layak melakukan percepatan pembangunan proyek PLTP di Indonesia. PT Geodipa Energi Persero adalah perusahaan yang bergerak di bidang energi panas bumi mulai dari eksplorasi hingga eksploitasi. Pada tahun 2011, melalui Peraturan Pemerintah Nomor 62 Tahun 2011, Geodipa ditetapkan sebagai Persero yang pengawasan dan pembinaannya berada di bawah Kementerian Keuangan dan PT PLN Persero, yang juga merupakan salah satu Special Mission Vehicle atau SMV di bawah Kementerian Keuangan dengan misi mendukung program pemerintah dalam penyediaan listrik tenaga panas bumi yang aman dan ramah lingkungan, serta memberikan manfaat besar kepada Indonesia. Geodipa siap untuk melanjutkan pengembangan proyek PLTP di Empatuha yang masuk dalam Fast Track Program atau FTP tahap 2 10.000 MW. Bagian dari program 35.000 MW yang merupakan program pemerintah di bidang pembangunan infrastruktur ketenagalistrikan. Saat ini, Geodipa menerima penugasan dari pemerintah untuk mengelola 4 wilayah kerja panas bumi. WKP DTT Dieng, WKP Area Patuha, WKP Arjuno Welirang, dan WKP Candi Unggul Telomoyo.
Geodipa untuk negeri.
Cuma rebahan, tapi bisa bikin perubahan. Waktunya mulai bisa apa aja dari satu aplikasi. Mulai adaptasi cara bayar baru.
Bisa kan pakai kris, jadi mudah.
Mulai eksplorasi cara tarik tunai baru.
Bisa lah. Dengan mobile tunai, gak perlu ribet.
Mulai melihat potensi bisnis baru.
Bisa dong. Transfer luar negeri cukup dari sini.
Oh, itu aja ya?
Enggak lah. BNI Mobile Banking punya banyak fitur yang buat kamu bisa apa aja. Bisa investasi, buat live goals, kirim digital kado,
Bayar tagihan rutin, top up e-wallet,
dan berbagai fitur untuk transaksi lainnya. Aku aja punya BNI Tablus dan BNI Mobile Banking.
Yuk, buka tabungan dan aktivasi sekarang.
Cukup selfie.
Dengan tampilan BNI Mobile Banking baru,
Mulai bisa apa aja sekarang.
Indonesia merupakan salah satu negara yang memiliki potensi energi panas bumi terbesar di dunia. Saat ini, Indonesia menduduki peringkat 2 dunia sebagai negara penghasil listrik dari energi panas bumi. Selain sebagai energi yang bersih dan berkelanjutan, peran energi panas bumi sebagai baseload penyediaan listrik menjadi pertimbangan utama agar pengembangannya diprioritaskan. Oleh karena itu, dalam menjaga ketahanan energi suatu negara, energi panas bumi dapat menjadi andalan untuk memasok listrik guna memenuhi target bauran energi 23% EBT di tahun 2025, sesuai dengan amanat dari Kebijakan Energi Nasional. Untuk memenuhi pencapaian target EBT, dalam bauran energi tersebut, Indonesia layak melakukan percepatan pembangunan proyek PLTP di Indonesia. PT Geodipa Energi Persero adalah perusahaan yang bergerak di bidang energi panas bumi mulai dari eksplorasi hingga eksploitasi. Pada tahun 2011, melalui Peraturan Pemerintah Nomor 62 Tahun 2011, Geodipa ditetapkan sebagai Persero yang pengawasan dan pembinaannya berada di bawah Kementerian Keuangan dan PT PLN Persero, yang juga merupakan salah satu Special Mission Vehicle atau SMV di bawah Kementerian Keuangan dengan misi mendukung program pemerintah dalam penyediaan listrik tenaga panas bumi yang aman dan ramah lingkungan, serta memberikan manfaat besar kepada Indonesia. Geodipa siap untuk melanjutkan pengembangan proyek PLTP di Patuha yang masuk dalam Fast Track Program atau FTP tahap 2 10.000 MW. Bagian dari program 35.000 MW yang merupakan program pemerintah di bidang pembangunan infrastruktur ketenagalistrikan. Saat ini, Geodipa menerima penugasan dari pemerintah untuk mengelola 4 wilayah kerja panas bumi. WKP DTT Dieng, WKP Area Patuha, WKP Arjuno Welirang, dan WKP Candi Umbul Telomoyo.
Geodipa, 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 Geodipa untuk negeri.
Ladies and gentlemen, welcome back with us in the second day of the 10th ITB International Geothermal Workshop 2021. For our participants, I'd like to inform you attendance form in the chat box that you need to fill. You can also watch video presentation from selected papers submitted to us on our YouTube channel at Geothermal ITB. Let us start our second section. Before we begin, I would like to introduce our moderator for the next two sessions, Mr. Alfend Rudyawan. Mr. Alfend Rudyawan is a professional lecturer and researcher at Institut Teknologi Bandung. He earned a doctorate degree in Geological and Earth Science at University of London. Please welcome Mr. Rudyawan. The time is yours.
Thank you very much, Mr. MC. So my name is Alfend, and I'd like to guide you into these last sessions of today. Before we start the sessions, I would like to invite our esteemed speakers to turn on the cameras for us, and then we will take a picture together. There you go. That's quite a fascinating views from here. Thank you very much. Please, committee, count on me. 3, 2, 1. All smiles. That's it. Thank you very much indeed for the pictures. Now, before we start the sessions, we have 2 or /3 speakers today. The first one will be Mr. Shakiru Idrissa Kajugus. Perhaps I spell your names in a better way, Mr. Shakiru, and then followed by 2 presenters, which are Mr. Dicky, Fahnudi, and Mr. Hulztsch. So, yeah, thank you very much. I'd like to give you some introductions about the first presenters, which are Mr. Shakiru Idrissa Kajugus. He earned the master degrees in geothermal reservoir engineering from Hulztsch Islands Geothermal University in Iceland. Now he is serving as a role in manager of research and innovations in Tanzania Geothermal Development Company Limited. Before we start the sessions for Mr. Shakiru, I would like to remind the audience that if you'd like to ask some of the questions, you may use the facilities from the Zoom meetings, or for you who are watching from the YouTube channels, you can write the questions in the chat section, the chat comments or chat sections there, and then we'll try to read it from you. 3 first questions that appear will be read to the presenters, and hopefully, if time permitted, we will ask more questions. So I'd like to ask Mr. Shakiru to get onto the stage. The time is yours.
Thank you, moderator. Maybe if I could I could share the screen now.
Yeah.
Okay. Can everyone see my slides?
It looks perfect.
Thank you very much. So I'm going to start. Yes, my name is Shakiru Idrissa Kajugusi, and I'm acting director of business development from the TGDC, which is the Tanzanian Geothermal Development Company Limited, and it's a company that's dedicated for the geothermal development in Tanzania, which was established in 2013 and it started its operation in 2014. So my presentation will go through this outline here: geothermal development context, then the strategy that we are having. Then I'll go to the status of the priority projects, then research and innovation, and I will conclude. So I'll try to go faster. I know that I'm given just 20 minutes to present it, and I'll be trying to be very fast. So I'm just going to start with this very important question: the why geothermal now in Tanzania? it's actually the government of Tanzania is now developing geothermal to support the Tanzanian Development Vision 2025, which has identified the energy as one of the very significant driving force, and to support the economic growth and the livelihood of the Tanzanian people. But it's also supporting, the geothermal development is also supporting the SDG 7 as well as the African Agenda 2063. But again, why geothermal in Tanzania is because that the country is now transforming its energy sector, and it's actually diversified energy mix. It diversifies energy sources so as to get to increase the energy security. And we know that increasing of renewable energy share is actually significant in driving in getting the modern energy as well as the environmental friendly source of energy. So another thing I think we are all knowing that is the advantage of geothermal, which are very, actually the advantages are just above the other source, many of the sources of energy. So the geothermal resource in Tanzania is estimated to be above 5,000 megawatts potential, with more than 50 sites identified with the different geological setting. And yes, the resources are we are having the resources systems in different systems. The low temperature system,
besar di atas 30%.
Hello? Should I continue?
Yes, please.
Okay, thank you.
Apologies.
So this slide here just showing the Tanzanian geothermal journey, which was started in 1976, and actually in 1976 was just recognized as exploration that were done, and the 50 sites were actually identified. Then in 2004, during the rural rectification studies, also did some of the geological, geothermal exploration, and actually identified one of the region is called Mbeya, which is located at a triple junction of East African lift system. That was one of the potential sites. One of the potential region for the further geothermal exploration. So after that recommendation, then in 2006 to 2013, the Tanzanian government actually did some efforts jointly with the BGR and the Geological Survey of Tanzania in doing some exploration activity in southern west Tanzania, that is Mbeya. Then the exploration came out with the suggestion that we should drill 3 temperature gradient wells, so that it will increase confidence of our site. Then after that, when these results came out, then the government saw that the need of establishing the dedicated company for the geothermal development. There is where the TGDC was established 2013, and they started to operate in 2014. And up to 2019, TGDC had already did the detailed surface exploration of 4 periodic sites, which is called Ngozi, Songwe, Kiejombaka, and the Luhoi. The Songwe, Ngozi, and the Kiejombaka are just located in southern west of Tanzania, which is where the triple junction is. And from the 2020 to 2022, the TGDC and the government is now focused on resource confirmation, and as well as direct use projects and the innovation projects. So the strategy of Tanzania, the geothermal development, the national geothermal targets we are having now is to have 200 megas into national grid by 2025, and some more than 500 megas for direct use projects by 2025. The approach is that TGDC should act as the national geothermal company, so that it can spearhead the development of the geothermal in the country. The strategic goal that we are having is implementation of strategic projects, research and development of geothermal sector, conducive actually to establish the conducive enabling environments for the geothermal development. This we are talking about the geothermal policies and the like, the guidelines, the plans and the like. Also strengthening of technical capabilities. That's mean the research as well as the human resources and the equipment and so forth. So these are the 5 priority projects that the government through TGDC are now keen in developing them, so that we attain the 200 megas targets by 2025. So we are having goals that we are now actually developing it to have the 75 megas as its contribution to the targets. Also, we are having the Songwe project, 500 megas. So this is the low temperature systems. The Ngozi is one of the volcanic system when it is a high temperature system. The Kiejo Mbaka is a fault control system, and it's also the low to medium to high temperature system. The Luhoi is situated in the sedimentary systems, and it's actually the low temperature system. The Natron is one of the volcanic system too. So these are the 5 priority projects that the TGDC is working on, so that we can realize the 2025 targets. And this is just a brief status of the priority projects. We know that the development of these projects in the next 4 or 5 years to come, it's a very ambitious targets that we are putting, the 200 megas targets, but we are trying to develop this project using different methodologies, so that we can actually speed up the development of these projects. Like the Ngozi projects, we are going traditional way that we are actually now in the phase of drilling, the confirmation stage of drilling whereby we are drilling the exploratory well, and to drill that, the government has decided to buy its own rig, so that we can speed up the confirmation works in other geothermal sites. So the Ngozi will be drilled using TGDC own rig, of which now the procurement is actually in the final stages, and we are expecting that the rig will be delivered to Tanzania. If all goes well with the procurement issues, then the rig will be delivered to Tanzania around in November this year. So when the rig arrives, then the drilling will commence. We are actually having now the consultant on site, the drilling consultant who is actually working with us, so that we can attain this. We can procure the rig, but to also make sure that we drill the exploratory wells, which are going to be drilled 3 slim wells with the maximum depth of 1.5 kilometers. So the Songwe project is now taken as one of the demonstration sites for the direct use projects, and to date we are on the final stages of construction of the geospa, the fish ponds, greenhouse as well as the chicken incubation farm. So after that, will be, these priority projects are being driven by have been fueled by the land of surface host, the land of hot water from the hot springs. And we are, this financial year, the 2021-22, has actually decided to drill the shallow wells so that we can actually confirm we can increase the confidence of our geothermal model in some way, but also using the flow, the wells, if they flows, using them to power these pilot projects. To fuel these pilot projects. The Kiejumbaka, this is another project which is a medium to high temperature system, and it's also in the resource confirmation stage. And the drilling, actually, we have concluded this month. We have concluded the drilling of 3 shallow wells up to 300 meters each, and the results are promising. And now we are actually doing the assessment of the fluids, the temperature and the pressure, so that they can be used for direct use purposes. But we are also planning to drill we are also planning to drill the slim wells, and the funding source are ongoing. And this is the plan for this financial year. The Luhoi project is also in the resource confirmation stage, and the fund mobilization is also ongoing, and the resource confirmation is expected to start. The plans and everything are expected to start in this financial year, the 2021-22. The Natron is actually is on the surface exploration phase, and the 2021-22 financial year is going to be studied to detailed surface exploration. About the research and innovation, as I've said, that the Songwe project has been identified as one of the demonstration sites for the direct use purposes, and we have started with the GeoHatch that our engineers here, the TGDC, have developed now the incubator, which is actually using the geothermal hot water to actually in the incubation process. And this has been tested and very successful one. We have done 3 tests, and the tests has about a success rate of more than 95%. So this is the technology is working, and in this financial year we are going to actually scale up these projects for commercial purposes. We have also done the swimming pools, and we have also done the greenhouse. All these are just in the pilot. We are doing this as the pilot projects, and we are expecting that the greenhouse, the fish pond, and the swimming pools will be, if they goes well, the tests goes well, then they will also be put into commercial purposes. So now it's actually the pilot that is going on. We have also developed the hot spring logger that is remotely monitored, and it's giving out the data, the hot spring data, back to our head office, while it is actually situated in the hot spring remotely.
Mr. Kajugus, unfortunately, the time is up. Could you make a final points to your presentations?
Thank you very much. Actually, the concluding remark is that the short-term target is actually 200 megas by 2025, and we actually local capacity building and awareness creation is also going on. Then we actually need the joint efforts from the Indonesian, the guru, the geothermal gurus, and the giants like you, we wanted to join efforts so that we develop the Tanzanian geothermal resources.
Right.
So thank you very much.
Well, thank you very much. That was a very nice presentations. I think they're all on points. Before we lead the questions from the audience, I would like to kick off the question and answer sessions by pointing out your last points of your concluding remarks. You say that we need to kind of work together. What kind of partnerships that is needed by Tanzania? I mean, we as an Indonesian working in a very different tectonic system, and you supposedly have a different tectonic system. So what kind of partnerships that is currently needed in Tanzania in developing the geothermal system there?
Okay, thank you very much for the question. It's actually the partnership, as you actually know that TGDC, I mean the Tanzanian geothermal development is actually still in the infant stages, I could say, and we actually need the assistance in all phases of geothermal development, like the exploration phases, the drilling that we are in now, as well as the geothermal, development actually during the development stages. So we actually need all the assistance from all the angles and all the stages, so that you can help us to develop this geothermal in the light way, because we actually try to learn from you, the giants, so that we can actually skip the mistakes that you have already encountered. So assisting us in every phases of the development will be very helpful.
Thank you very much. I guess we can pull up some of the questions from the audience. I think this is from your fellow countryman. I think I think I know him. He's asking about how did the government involve for achieving this project development goal? So when you success in explorations, then how will it contribute to the energy diversifications in the region to be more broad?
If I could start with the first, question, that how do the government contribute to the energy, to the geothermal development? It's actually the government, the geothermal development budget is actually coming out from the government with the large portion of the geothermal development budget is coming from the government. So that is already showing its contribution and the seriousness and the efforts toward development of the geothermal. Also, the establishment only for the TGDC establishment, the dedicated company for the geothermal development is also the efforts from the government. But the rig that we are going to buy, we are going to procure, is also being funded by the government, 100% from the government. So I think it's enough contribution that the government is trying to put, and it's the seriousness that the government is having toward the development of the geothermal. So that's that. Again, if you could repeat the second question, I don't know if I got it correctly.
So perhaps you already answer it in a certain way, where when you explain the government will do something about regarding the energy distributions. I think you already mentioned it, but not in a clear way. But I think if I can rephrase the question, so how can the geothermal have a role in energy diversifications in the region? So can we rely on geothermal in your part of Africa, for example?
Okay. Actually, as I've said, that the geothermal has a very significant role as one of the renewable source of energy. Our power system master plan, the 2020 power system master plan, has already identified has already showed the direction toward the transformation of energy system in Tanzania. So the power master plan has clearly identified that the geothermal should contribute at least 200 megas by 2025. And the other renewables, the total of the renewables, renewable contribution for the Tanzanian energy sector is about 1,300 megas from the other, from the all sources of renewables, the solar, the geothermal, winds, and the like. So the contribution of geothermal is very significant for our energy sector.
Thank you very much for the clear answers. Do we still have some minutes? So I think this is the third, perhaps last questions from the chairman of the meeting, Ms. Suryantini. So she asked two questions. What is the major obstacles for geothermal development in Tanzania? That's the one. And then I think the second one is already being discussed, but you can add some more points into that. How may Indonesia assist your geothermal community in Tanzania?
Okay, the first one, the major obstacles, if I could go very directly, you know that the geothermal has no, we have, in Tanzania right now, we do not have the clear geothermal registration, but this has been now, now the government has taken the efforts to actually establish to actually establish clearly enabling environments, the geothermal registration. Now the government is in process of establishing this, and we're expecting that before this year ends, maybe we'll be having the special geothermal law. So this is one of the very big obstacles, but the government has already seen it and is working on it. Another obstacle, to go quickly, is about the funds. We know that this is a very common obstacle for geothermal development or for any project development in anyhow, the funds are always limited. But another one is about the capacity, the human resources. We do not have the academic institution do not offer any geothermal courses or professional courses. So, but this has already been seen also by TGDC as well as the academic institution. We are now actually working hands in hands with some of the institutions so that they establish these geothermal curriculums and so forth. So about if I go to the second question about the assistance that we need, if I could say very clear, maybe quickly, the first assistant, we know that, I know one of my colleagues there, the Tanzanian one, is studying in Indonesia. So this is actually, if we could get the assistant from Indonesia, maybe I could say the first is the capacity building, which is, this long training, the masters and the PhDs, that could be very helpful for our sustainable geothermal development in the country.
Well, thank you very much. I think that was some enlightenment from Tanzania. I think we can all agree on that. Thank you very much. Very much appreciated for you coming here today. As a token of our appreciations, the committee will contact you regarding these memento. So thank you very much for attending the seminars today. I hope we can all meet together in a better conditions in the future.
Thank you very much. It's my appreciation.
Thank you. So for all the audience, I think we will come back here at the same place. It's 3 minutes from now. There will be some ad from our sponsors. We'll be right back. Stay tuned. See you in a bit. Hello. We're coming back to the final sessions of today. There will be two speakers following up these introductions. There will be Mr. Dicky Fahnudi and Mr. Paul Hulztsch. I hope I spelled your name right. They both going to present about the fracture identifications. First up, I think I'll lead it to you both how to split the presentations. But first up, there'll be Mr. Dicky Fahnudi. He's he's petroleum engineers from Institute Teknologi Bandung. Now he's serving as a division manager of digitals and integrations for Indonesia in Schlumberger, Indonesia. And then there'll be Mr. Paul Hulztsch. He had a master's degree in petroleum economics from University of Texas. Now he's a members in a digital subsurface and consulting manager in Schlumberger, Indonesia. So I leave it to you both to split the presentation. So I would remind the audience to put forward your presentations via chat box in the Zoom meeting, or type in your questions in the YouTube comment sections. I leave it to you guys. The stage is yours.
Okay. Yeah. Good afternoon, everyone. Can everyone hear me okay?
Yes, clearly.
Okay. Thank you, Parvin. Yeah. I think first of all, thank you for this opportunity. I think both me and Paul, I think we are very happy to be able to participate in this event. Right. The topic that we will share in this forum is about how we use digital innovation for optimal well placement in the geothermal, right? I'm currently in Jakarta, but my colleague Paul, he's going to deliver this session from his vacation in Madrid, Spain. So appreciate to take the time, Paul. All right, let's just get started. So what I will do, I will just introduce the topic, provide some context, and then I will leave the difficult part to my colleague Paul. Hang on, let me. All right. So, we are known to be, the oilfield service company, right, in the oil and gas. However, since many years ago, we've been participating in geothermal market, particularly in Indonesia. And in the recent event, our CEO said that the new energy is going to be Schlumberger engine for long-term growth, right? Did require some shift, right, into the low carbon and higher value generation, right, in the new environment. So on the right side, you can see that in addition to our existing oil and gas, we started making investment in the new energy, namely hydrogen, CCUS, geoenergy, lithium, bioenergy, and geothermal. And geothermal plays a key role in our new energy strategy. And on the left side, our approach to the new energy is based on technology and partnership, right? Building on three of our core strengths. I think the first one is our subsurface domain expertise. This is why we have Paul here. That is applicable beyond oil and gas. Whatever we can implement to the adjacent market, we will do, right? So we can save the learning and then, maximizing, right, the value for whatever existing solution. And second, our track record on innovation in utilization. And number three is that our ability to scale up, right, in the country where it operates with local talent. Yeah, this is very important. So obviously, geothermal is a key part of our new energy portfolio. And Asia in particular is big in geothermal, right? We are the second largest producer. And I think the three of the top 5 geothermal producing countries are within our region. So the challenges that the operator or geothermal operator face across the world is essentially come down to two things, right? How to reduce the drilling costs, i.e. how to reduce the dollar per well. And second is how we can resolve the uncertainties around distribution and productivity, right, within the areas in the field, i.e. how to increase the megawatt per well. So I think these are the two drivers for the solution that we will be sharing on this session. A quick one, both myself and Paul, we are part of the digital integration division. So our division is one of the 4 divisions in Schlumberger, and the reason we put together digital and integration in one division is so that we can provide an integrated approach, right, from subsurface characterization until the field execution, the drilling, the production, right, while leveraging the digital leadership and applying any potential technology and solution, including geothermal, which can be one of these, either accelerating exploration or improving the well targeting or reducing uncertainty or optimizing the operations. This is what we do, right? We have a team of about 2,500 geoscientists and PTEs worldwide, and we are trying to leverage whatever digital solution available from the oil and gas into the geothermal. And the last, before I hand it over to Paul, we have extensive experience and footprint worldwide. I just plot a few of them, the important ones. I think we have done the reservoir modeling, right, in Geyser Field. This is in the California. And I think the interesting one here is that the Celsius Energy, I think the one in the middle. So this is our new energy business venture focused on heating and cooling. So what we do is actually we utilize the geoenergy powered by Earth, right? And then we plug in this into the building so that we can have a continuous and resilient energy source to deliver heating and cooling while reducing the CO2 significantly, right? I think the point here is that really how can we take the solution and innovation, right? Be it from oil and gas, be it a fit for basin or specific localized challenges to deliver the performance. So how can we apply, right, or bring the value, right, through digital innovation? I think this is the segue into the heart of the matters that my colleague Paul will deliver. I think now the forum is yours, Paul. Go ahead.
Thank you very much, Dicky. Can you hear me well?
Yes.
Okay,
clear.
very good. Good afternoon, everyone. Good morning, if there is anyone in this part of the world. So yes, Dicky mentioned challenges and industry challenges. So to start with the more technical part of the presentation, I have listed here some of the key challenges remaining in geothermal. Yes, and some of these challenges can be tackled very effectively by digital innovation. For today, I will talk about one example, right? This is by no means the only avenue we are evaluating and pursuing, but it's one of the key examples. Is relevant because a lot of the work has been done in Indonesia, right? And but it's intended as an example of the bigger effort to move into digital transformation for geothermal. Yes, so it's more about the building blocks of the solution, digital building blocks. I'm not going to talk about specifics of projects or results. That's not the purpose of this presentation, right? So thank you very much, Pak. Could you please go to the next one? Okay, so the starting point for this solution, digital innovation solution, is the existing body of work that we see in well placement, not only for geothermal, but there has been a lot of work done for sweet spot mapping, for mature fields, also for naturally fractured reservoirs. And some of that work, some of it based on oil and gas, it can be used as a starting point to find a well optimization tool for geothermal. So what you see in your screen is the workflow that we generally use for well placement optimization to identify sweet spots map for oil and gas, but also in this case adapted to with some elements of geothermal, right? And we start from the 3 Gs that we use in geothermal for conceptual modeling, etc. And we add two new elements which are geomechanics and geostatistics, and integrate all of them into the workflow that you see there. The objective is to generate sweet spot or hotspot maps that can identify more productive areas or fractured areas in the geothermal reservoir. It's based on the work majoritarily from the team in Indonesia, but also is the result of a collaboration with one of the main geothermal operators in the country, right? So, and we call this the 5G workflow, right? Next one, please. Okay, so this diagram sort of summarizes one way of looking at digital transformation into geothermal. So these are some of the building blocks that I mentioned earlier, right? So we're looking to utilize all the data available, or as much as possible, right? And minimize the time spent on performing tasks, time spent on repeated tasks. So I think this goes to the question whether artificial intelligence or digital innovation is going to replace the domain knowledge. And the answer to that is no. It will complement it, it will accelerate it, facilitate it, but the idea is not to replace by any means the domain knowledge behind this. I'll focus more on digital today. And finally, the idea is to reach an outcome that can help inform decisions or can help make better decisions or operational decisions on drilling, production, so on and so forth. So this is what we consider to be the building blocks of our solution. Could you please go to the next one, Pa? Okay, and just to a little bit more description on the building blocks, this is a methodology that was developed by the team in Jakarta to try to characterize, use all the data from the wellbore as a starting point to characterize the fractures, their distribution, but also their productivity, right? Are they open? Are they closed? Are they open and conductive, productive? So in our experience, the answer to that question doesn't come from a single log, a single bit of information. Is about the combination of the relevant data into fracture characterization that can then be used to try to propagate that understanding into the reservoir level. Next one, please. Okay, so and here we get to the a key part of the process, which is how can we, from information from the wellbores, can we build fracture models, right? And the key to that, and again, this is something that we developed or we looked into for oil and gas first, but the idea is to break up the problem of finding the fractures into different geological events. As you can see there in the slide, fractures are the results of various geological events. So rather than try to capture everything, we break it down into what we call drivers. Some of the drivers are used in oil and gas, like distance to fault, fault-associated fractures. But in the geothermal work, we need to make some changes and adaptation of these drivers to make sure that we capture geological events such as intrusions, which are so important for geothermal. So this is also part of the innovation for this particular application, for this particular digital solution, right? And it helps capture the fractures in a way that the traditional methods cannot do. But it also it leverages on the digital power to be able to bring back all these separate fracture models into a single one, and to be able to generate permeability 3D models out of that. The next one, please. Now, the reality is that if we have only a few control points at the wellbore, we will extract all the information from there, but we are filling in the gap with understanding of the structure, the know-how and understanding of the reservoir from the operators. But there is no single answer to what the subsurface looks like. So in order to capture, to understand and quantify those uncertainties, we will run next one, please. Just one click. Okay. We use multiple realizations. We are not looking at a single model. We need to look at tens of models to the extreme. We're talking about hundreds or thousands. But in general, what we are trying to capture is what are the what if scenarios. If the intrusion is not there, if the faults are not there, is the parameters we're using are not fixed or sensitive. So how are we going to capture all these different variabilities? And again, digital gives us now the possibility to run multiple realizations a lot faster than in the past. So this type of approaches is now taking a lot of speed, gaining speed in oil and gas, but also in we see that it's very valuable for geothermal, where there are significant uncertainties, particularly towards the earlier steps of the process. So next one, please. So of course, we can come up with tens or hundreds of models, but how are we going to inform a decision? And in this case, there is as well significant advances in drilling, in drilling engineering, drill planning, etc., that can be combined with the results from a digital solution on permeabilities, etc., to guide the actual drilling plan, but also to monitor against the actual drilling operations, right? Identify potential hazards, so on and so forth. So we see that beyond just the digital realm, there is a possibility to make a connection with the execution part of the operation, right? So this is something that is important for us to push it further and to try and achieve it, whether in drilling or production. So ultimately, if we follow these rules, right? If we accelerate the next one, please. If we try to combine the power of digital with domain knowledge to design solutions that tackle specific challenges, key challenges in the geothermal industry, we believe that we'll be able to have the type of impact that Dicky mentioned, is reduction of the uncertainties and a reduction of the operational cost. So what we see in this slide is a graph that has been extracted from information from ESMA, right? That shows in orange the traditional risk profile for geothermal assets, and in blue what we see is the cost. So yes, there are areas towards the test drilling, feasibility study, and development drilling where the cost is quite significant, the investment is significant, and the uncertainties are still relatively high. So we do feel that with a combination of different digital solutions and digital innovation, we could be able to improve those risk and cost profiles ultimately, so that the industry can see an improvement in attractiveness of certain assets, reduce uncertainty at key steps of the process, right? And these are just in the right, are just a few examples. More accurate resource assessment, multi-physics inversion, more towards the exploration stage, for example. well placement optimization, sweet spot or hotspot mapping, as we mentioned, improve forecasting with uncertainty ranges. And as we move into stages where we have more data, like more mature stages of the field, we then have enough information to use production and drilling analytics and to feedback and improve those models so that we can improve our operations, both on production and drilling analytics. So I think this is the last slide there is one more. Okay, so on key takeaways, I think Dicky has already talked about how important geothermal is for Schlumberger as part of our new energy corporate strategy. We have leveraged a lot from the global and local expertise from geothermics, from digital, from the different teams in our company, right? To try to put together solutions that could be relevant and viable for geothermal. But of course, that also requires to make this feasible and viable. That also requires a participation of the industry and collaboration with the industry. I already mentioned collaboration with one geothermal operator in Indonesia, and that has been key to improve some of these initial ideas and to make them viable and possible. Right? So another mention. So there's always understanding geothermal, understanding the technology. So there needs to be a combination of the two. There are a lot of advances in digital that are allowing us to evaluate, for example, multiple realizations, that are allowing us to use machine learning and AI to understand thousands or millions of data points for production and for drilling, right? So there is still a huge area of where we can improve, but we need to go in there with a very good domain knowledge, a good understanding of the reservoirs, to make sure that we can build the solutions that are not just a mathematical construct, but that really support key decisions for the operation and the exploration of geothermal assets. So thank you very much. Dicky, would you like to add any point?
No, I think, Paul, you covered all. I think that the point is that I think we apply whatever possible solution we can adapt from the oil and gas. And also, I think we should take the opportunity to leverage the advancement, right, on the digital. I think the previous panelists talk about machine learning, right, coupled with the high compute power. I think we should really take advantage of the technology, right, to deliver the value in the geothermal. And then I think the last is that I think many of the local problem can also be solved, right, by using digital, right, including something that doesn't exist. I think, again, in the previous session, I heard about using AI, for example, right, to predict the stack pipe, right? I mean, that's the kind of thing that I think we should, as a community and industry, I think explore more and then collaborate together, yeah, for the advancement of geothermal in Indonesia and globally. I think thank you very much for the opportunity. I think we can now move into a Q&A. Yeah, thank you.
Thank you very much for Pak Dicky and Sir Paul for the enlightening presentations. Thank you very much indeed. So I think I'd like to kick off the Q&A questions by asking about how would you kind of connect from a very high resolution data in borehole image to another type of digital data. Say I'm a field head, so I will often go to the field and I record all the data, and I'm making a digital models of outcrop, mapping the fractures and mapping their digital interrelationship perhaps. So how that can be set in in your algorithm. So where does that sit in your algorithm of creating this when you develop your algorithm?
So okay, so that's a bit more specific on the technical, but as you pointed out, Alfend, you would get idea of deep and azimuths from a very detailed wellbore image, right? And you would characterize and you would say these are the deep and the azimuth, and also you would put a flag and say this is conductive, open, closed, so on and so forth. Right? So, but there is a lot of information there. What we do is that information about the deeps, for example, can also be contrasted against the conceptual model of where the main faults are, right? So you can say, I have a main fault that goes through this in my conceptual model, goes through this well. So you can compare the deep and the azimuth of your interpreted fault against the deep and azimuth of the wellbore image at that particular interval, for example, right? So if they match, you can then say, okay, most likely the fractures that I see in my wellbore image might be caused by faulting. And you can do a similar analysis when it comes to intrusion. The trick here is that you're never completely certain that the fault is through where you draw it or your intrusion. So that's why it's important that you test it and you check different hypotheses to do that. I hope I answered your question.
Yeah, that's very much what I was hoping for the answer. So I think we have plenty of questions from the audience. Could the committee pull up some of the questions? This is from After at ITB. He said that Schlumberger has magnificent work as a service company, especially for oil and gas sector. So when you switch to geothermal, what is the main challenges to change this? Well, the views of the publics when you're working with clean energy.
Sounds like a question to Dicky. Dicky, let me know if you want to answer that.
So, let me try to answer this, right? I think the truth is that a move into lower carbon, I think let's call it that way. I think the person who posed the question call it clean energy. I think let's call it lower carbon world, right? It's imperative. I think, as we all know, I think it's not a choice. I think we are in the transition. I think the train has started moving. I think all the industry players are actually getting on board, right? I think the fact that for us, Schlumberger, we have been working in geothermal in Indonesia since the 90s, right? I think geothermal is even much older than that. I think it was an opportunity that now, the difference is that now, I think it become more and more feasible so that many company, including an oil and gas operator, that make a move into geothermal, an oil field services company or drilling contractor that previously not in the geothermal now wanted to get into geothermal. So it is an imperative, right? It's a must, right, to develop and make progress, right, in the geothermal space. The good news is that there are many technology solution, workflow practices in the oil and gas, which is already a very mature industry that can be applied either as is or with some customization into geothermal, right? And this is what we are doing right now, whether it is a drilling technology, monitoring, or completion, right? Some of them can be used as is. Some of them require some specific customization that we have to do. But I think the answer to the it's not difficult, but it requires some investment, and the most important thing, require partnership, because for the reason that I said earlier, there are many uniqueness in the geothermal. Right? I mean, if we talk about drilling practice, for example, geothermal, we are after losses, right? It's a high temperature. This is something that occur once in a while in the oil and gas, but this is what we want to happen in the geothermal. So it's not really a choice today. I think you will see more and more many oil and gas players making a move and putting investment right into geothermal just because we have to do it. It's imperative. Yeah. Thank you.
Well, thank you for the strong message there. I think green energy is imperative, and we need partnerships. That, I think, 2 points that I get from you. Thank you very much for the answer to that questions. And then the next one, it's from Bagus at Geothermal ITB. So how can your technology and data information system reduce the risk of drilling problems such as stock pipe and so on? I think you mentioned it in a short way previously, but perhaps you would like to elaborate on that.
Yeah, so I think there are two ways. The first way is when there is enough data, right, in a mature field, you have a lot of the previous wells to go by, right? So of course we can interpretatively, if you want, mark, okay, so there was a problem in this field, in this well, there was another problem in this well. And then you can use that information to sort of identify potential hazard areas if there is consistency of those, right? So, and that's part of solutions like Rig Hour that uses all the analytics and try to understand performance, but also can be complemented with drilling hazards, so on and so forth, to avoid problem areas as much as possible, but also make sure that you stick with the right operational practice, right? And this is key. It's not only about the information that digital is giving you, is combining it with domain knowledge or operational best practices. The other way you can try and solve it is predicting. If you have built a model or several models, you can then identify this area might present some issues with drilling, right? Because we see there that there is a specific orientation of the fault that we need to navigate, work around it. So based on models, more predictive models, you can also complement that understanding of your recent experience, right? So these are two ways.
Thank you very much. There'll be, I think we have quite a few questions here. Some of them are technicals. I think this is the third one. Since we are working in the geothermals area where perhaps seismic data are not viable or are not being the main data that we are using, so how can Schlumberger increase the resolutions of data acquisitions in volcanics and igneous rocks where we relied on these geological setting in terms of geothermal systems?
Yes, and there is not, the reality is that there is not a single bullet, right? The type of resolution and detail that we get from seismic in some carbonates or in other fields cannot be compared with the information that the conceptual models that are put together from magnetotelluric and different geophysical measures, plus the combination with pressure and temperature, and of course some surface geology. So and geochemistry, but there are new. One of the options I mentioned, multi-physics, is that there is a lot of work that's happening in combining magnetotelluric, Krav Mag, and other wellbore and surface measures to make sure that by combining them, you get a picture that is more geologically feasible, but that it also satisfies the conditions of the different geophysical surveys. So this is another area that I have not explained today, but this is part of the work that our team in Milan continues doing. Yeah. simultaneous inversion, right?
I would say this is part of your evolved workflow you may present.
Correct. Well, I've been very specific on what we're talking about well placement today, but there are other initiatives that are ongoing in Schlumberger that tackle production, more towards the exploration as well. So the idea is that the combination of some of these tools can eventually, put us closer to reduce uncertainties and reduce costs.
Thank you very much, Paul. So come up to the next questions. This is from Licia at ITB. I think it's pretty much similar, but it has some differences in the points that she was asking. So in volcanic terrain with multiple events of eruptions, so how can we make an image of those events?
Yes. Okay. So the images are captured, of course. The fractures that could be caused by intrusion will be captured in the wellbore image in a similar way that we capture the fractures that are formed by folding or faulting, right? The idea is to sort of characterize it or try to understand what is at the reservoir scale the impact. So particularly for intrusion, we use a driver that takes the wellbore images as input and also calculates the far field stresses. It's a geomechanical engine that will calculate, will try to solve some inverse problem and compare it against what we are getting at the wellbores and what we are getting at the and what we propose as the original intrusion geometry, right? It's a model. So this is particularly the most complex part of the workflow, to be honest, and it's difficult for me to explain it in a couple of minutes. But yes, we use some geomechanical engines to try to understand what is going to be the impact of the intrusion and compare that against the control information, the calibration points we have.
Okay, thank you very much, Paul. We still do have some questions from Taha at ITB. So in terms of development drilling, how can these results of the fracturing models will be helpful for the next well design?
Okay, so I think the key the key to that is to try to understand predictability, right? Of course, if the naturally fractured reservoirs does not behave like a sandstone reservoir, where if you have a couple of wells or 3 or 4 wells in the vicinity, you can predict more easily what the result from the next well is going to be. In naturally fractured reservoir, those type of changes, I mean, you could have a good producer, and 500 meters away, you're gonna have a very poor producing well, right? So you need to you need to make the models more predictive, and this is what we're trying to do by throwing just statistics and geomechanics into the models, and the results of the models are maps with predictions, or models, 3D models with predictions as to where are the better areas in the reservoir. Of course, if we have several of those models, we can have sort of an uncertainty range, and this is how what we see if operators focus on the areas that show the more consistent hot point, right, or hotspot, with the lower risk, then this could be used to drill the next wells, right? In a development scenario, in a makeup well scenario, it becomes a lot. It becomes more difficult when at the test drilling stage, where you only have a handful of wells with the information. So, but this is also some of the angles that we're looking into. How many wells is enough?
Mm-hmm. That's true. That's true. Thank you very much. Okay, I think this represents also my questions. From Idrissa, I think this is our previous presenters, from University of Dodoma. Are the geothermal development data open for academic research? I think the one belonged to Schlumberger, or Schlumberger had the hands to some of these data, perhaps. Are they open?
No, the short answer to that is no. As you can imagine, based on the slides that we have presented, this require wellbore images. It requires interpretation, etc. And these are not publicly available to all the operators, unfortunately. So these are the proprietary of the operators we collaborate with. We have evaluated a couple of years ago using just public data, right? But it was always incomplete. It was difficult for us, and also that interpretation element in it was missing, right? Understanding of the reservoir. So this is something that we need to do for the geothermal operators based on the data that they have. Behind this solution, and I failed to mention it earlier, are Petrel, for example, some of the tools that we have already developed over many years to tackle these type of complex problems as well, right? But it's this is what we bring to the collaboration, what the geothermal operators bring: data, know-how, and a lot of understanding of the reservoir. So this is key.
Okay, always a very concise and very clear answer to the questions. So I think you mentioned this earlier, but they've been put up by the committee, the questions, asking about the accuracy. So the accuracy that you'd have from these very robust drilled data, so well data. So how does the accuracy of the borehole imaging from the geothermal to the oil gas field? I think they use the same. Are they use the same tools, or are there difference in accuracy, perhaps?
I think the main difference is the temperatures, right? That the wireline tool, for example, had to endure, and this has been a limitation in geothermal, in certain high temperature areas in geothermal. For a while, my experience is that for some of the fields that we've seen, that we've logged and that we have interpreted, that there is still significant information that can be extracted from an FMI, for example, right, to be used in that can really return this a far better understanding of where are the fractures, what are their characteristics, can we sort of line them up together to see a bigger picture. So in general, I would say that in geothermal, this type of information is not used enough, and based on the workflow and the solution that we see, we definitely believe that the investment is justified compared to the possibility of drilling a well in a completely in an area that doesn't turn out to be as productive or as practical to drill than if you had this information.
Excellent. Do we still have questions left, committee?
It's good. It's fantastic to have this many questions. I'm running out of voice. Let me see in this.
Right.
Based on your experience. Yeah, go ahead, please.
Yeah, I think you can read it by yourself. So include based on your experience. So how often are the intrusion-related fractures found in geothermal areas, and what's the likelihood of its probability?
Well, that's a difficult question to answer because I don't think it's a one size fits all. But it will depend on the reservoir, right? We do see. We do expect that intrusion is going to have a big It's going to be a big contributor to the fractures, but again, it will depend on it will depend on each case. I cannot tell you how often you will have.
Right, I think that will be our last questions for the last sessions of today. Thank you very much indeed for your enlightening presentations. Many of us learned a lot today. If I may summarize from the last sessions of today, first, I think we have three main points here. First is partnerships between communities and geothermal heads in different parts of regions. And then the message from Schlumberger is green energy is imperative. I think that's a good point to convey to people who watch our meeting today. And we have to still to be open in the evolving algorithm or evolving workflow so that we can be better in terms of predicting or interpreting or anything related to our aims in exploring geothermal energy. So thank you very much again for your presentations, Dicky and Paul. There will be a memento, well, two mementos perhaps for you and your team, for Pak Dicky and Pak Paul from Schlumberger, as a token of our gratitude for your participations in our meeting and for your enlightening presentations. Thank you very much. I personally myself learned a lot today. So I think when we finish these sessions, I think this is at the end of our last sessions of the day. My job, I think, is to guide you to get through these sessions. Thank you very much again for all of these speakers and all the attendees for participations and your lively discussion. So I'll hand the baton back to Mr. MC. Thank you very much. I hope you enjoyed the session.
Thank you.
Okay. Yeah. Thank you, Mr. Alfend Rudyawan, who has guided us as a moderator for the interesting discussion. Thank you, Mr. Shakiru Idrissa Kajugus, Mr. Dicky Fahnudi, and Mr. Paul Hulztsch for a great insight. According to our clinometers, it reads about 300 participants in Zoom that are live with us today from all over the world. While on YouTube, we have more than 100 live streamers. Keep sharing and join us. We come back with interesting 10th event. Now the end of the series of 10th ITB International Geothermal Workshop is near to end. At the moment, we'd like to give our highest gratitude to all the invited speakers, all the moderators, and for all the participants. It's our privilege to acknowledge all our sponsors. Our gratitude goes to and the organization that endorsing for this event. And for the organization that's supporting this event. My gratitude also goes to media for advertising this important event. And we would like to remind you that there are still 2 days left in the series of virtual 10th ITB International Geothermal Workshop, starting from 2 until 5 p.m. Jakarta time. For tomorrow's agenda, the topic is utilizing non-conventional geothermal energy. You can check the details of tomorrow's agenda on the bumper video at the end of today's event. Don't forget to subscribe our YouTube channel to get an interesting information related to geothermal. Last but not least, for those who have paid to get the certificate, please check the chat box and fill the participant attendance form. We'll send the certificate through your email after the event. Due to the limitation of time, unfortunately, not all the questions can be answered during the event. Also, you can watch the replay footage of today's agenda on our official YouTube channel at Geothermal ITB. Eventually, this is the time for us to say goodbye. I am Rian, your host for today. Hoping to meet you soon. Thank you and stay healthy. See you tomorrow.